All right, so this is your notes for variables on both sides. Special cases. All right. So what happens here to ask you the first two, in your own words, describe what a solution is to an equation. So you can come up with many different ways to what a solution is to an equation, but what you should know what a solution is basically it's the answer to an equation that is true. And that is a big word right there, true. So that's what we're looking for. We're looking for things in these special cases that have to be true. And if they're not true, then we can say, well, there is no solution to this equation. Because sometimes we won't ever find a solution that will satisfy the equation. But if we can find an equation, a solution to the equation that is true, we can say it has one solution. Or we can also say that it has infinite amount of solutions. I mean, any number that you can pick from. And yesterday, what we talked about in the last video was equations with one solution. And these are what the first two are. And we should be able to solve those two first equations if you want to solve those. So the thing is, if we want to solve these two equations, you just need to make sure to move the variable to either side of the equal sign. And I'm going to move the variables to the left-hand side in this video just for repetition in this case. So in this case here, this equation here, when I solve it, will have one solution that is true. So what I'm going to do is I'm going to move the 7x over to both sides, just like so. And when I do, these 7's cancel out, become 0. And I have 2 minus 7. I can put that in my calculator. 2 minus 7 will give me negative 5 minus 5. And this will all equal what's left is the 20 because he's going to come down. I have 20. So now what I need to do is solve the equation, the two-step equation that I have right there. The negative 5x minus 5 equal to 20. And what I need to do there is just basically the same thing. Add 5 on both sides. And I get negative 5x equals 25. And then divide by 5 on both sides. And what I'm going to find out is my one equation that is true is that x equals negative 5. So that right there would be my solution for that one. That's my one and only solution that makes these two equations true. Okay, so far we've done that. Here's another example here of a one-step equation that you can work on. You can clean this up and make it. You got to clean this up right here by doing the distributive property. So that's 2 times m and 2 times 2. So it gives me 3m plus 12 is going to equal 2 times m plus 4. And like I said, I'm going to move a variable over to the other side to get the variables on one side. So I'm going to always move it over to the left here just for this video. You can try the right if you want to, but just for this, I'm going to move it to the left. Those cancel out. And I'm left with m plus 12 equals 4. And then this is a one-step equation here where I need to know what can I add to 12 to get 4. Well, I need to subtract, and it's going to give me a negative 8 for that answer. Okay? Well, that's all fine and dandy. Those are all one-step solutions. We've done this before, big deal. But this is where we come to our special cases. And here's my first special case right here. This is my case number 1. This is equations with no solution. Okay? And that means that we're not going to find a solution that's going to make everything true. It's going to be kind of weird. And let's see what happens. We're going to see that there's a pattern that involves that will be able to help you be able to solve these. These are just like what they ask you on the IXL W14. So if you can do W14, you should be able to do these. Or if you can do these, W14 will help you. So let's take a look at this one. I'm going to move every variable over to the left-hand side and solve. So there's 7n. He's plus, so I'm going to subtract. And I'm left here with 7 minus 7, which is 0. So I can cancel him out. And then I'm left here with 7 minus 7 again, which is 0. So I can cancel him out. So what am I left here with? Well, I'm left with the -3, and it's saying it's equal to a 6. Can a -3 ever be equal to a 6? No, that's not true. So that right there means there is no solution there for that problem. Okay? Let's look at another one and see if the pattern emerges. So here I need to clean up. So I'm going to clean this side up here by distributive property. I'm going to do 2 times 4, which gives me 8y, and 2 times -5, which will give me -10. And then on the other side here, I need to combine these terms. So 3 plus 5 gives me 8y. And for this case here, since we have one term, I'm going to move him over here to this side. So I'm going to subtract 8y from 8y. And I get 0 here. And I get 0 there. And I get -10. Can -10 equal 0? No, it can't equal 0. So we know that's not a true statement either. Well, what did these two have in common? Well, if I look back at these problems here, I'm going to take my highlighter, at the original problem here, and I look at the variable terms, it looks like they both had a 7n and a 7n that are the same. If I look down here, and after I've cleaned it up, I have an 8y and an 8y. The variable terms were the same, but the constant terms were different. So that tells me right then and right there off the bat that since the two variable terms are the same and the constant terms were different, I'm going to have a no solution because the constant terms are going to cancel out because they're the same, because I got to do the opposite. Because see, the 7 and the 7 are the same, so I got to do the opposite, subtract both of them. So a positive minus a negative, and if they're the same, it goes to 0. So down here in my own words, here if I have a no solution, no solution says if my variable terms are alike on both sides of equal sign and constant terms are different. So there's that right there. So that's pretty much the definition. And you will be able to see that that is a no solution. That means you can never find anything that will satisfy that equation. These are not true. So we know that this has no solutions. There's no answer that you can find for that. But you have to prove it though. You have to prove it by either stating the definition or solving the problem out. Okay? The second case is when there are infinite solutions. Infinite solutions. That means there could be any answer for this one. This is my second case. Case number 2. Any answer could match up for this one. So let's see what happens why. So I'm going to clean this one up a little bit. I'm going to clean this up right here. So I get 2x plus 6 equals, multiply the 2 times x, and the 2 times the 3. And I end up something like this. I can solve this problem here if I wanted to by moving the x's over. 2 and 2 go away. The 2 and 2 go away. And all I'm left here with 6 is equal to 6. And that is true. Okay? You do the same thing here for this one. If you notice, I got 3c plus 2 and then another 3c plus 2. Those are both the same. If I solve this one by subtracting my 3c's from each other, because they're both positives, they go away. I'm left with 2 is equal to 2. And that is true. So you can see here, well, what did they have in common? Well, what they have in common was both sides of the equal sign were exactly the same. When both sides of the equal sign are exactly the same, I started with a 2x plus 6 is equal to 2x plus 6, and a 3c plus 2 is equal to a 3c plus 2. Those are exactly the same. I'm going to get something that's going to be infinite. I'm going to get any answer will be the answer for that. And I just proved it right here. 6 is equal to 6. Well, that's always true. It doesn't matter. Any value I want to pick for x will be an answer. 2 equals 2. Well, that's true. That means any answer, any value I put in for c is going to be true. If I wanted to put a 5 into here, 3 times 5 is 15, plus 2 is 17. 3 times 5 is 15, plus 2 is 17. It works out both ways. Okay? So if we write our definition down here, a infinite solution is when the variable term and constant term are both alike on both sides of equal sign. So that is the definition there for that. That they're on both sides of the equal sign, that both the variable term and the constant term are both alike. So they have to be both the same. And please refer to this. So when we solve these problems, you either got to work it out and show me. You'll get something that it looks like this. Or you can recognize it and state the definition. That's what you're going to be asked to do. So these are the kind of notes that you need to refer to. We know how to solve a one solution problem. Get the variable on one side, solve the two-step or one-step problem. Here, you need to either recognize that both are the variable terms are the same and the constant terms are different and say, no, this is a no solution, or work it out and you'll get some sort of funny answer where a negative 3 can't equal a 6, or a negative 10 can't equal a 0. Okay? Or you need to be able to recognize, hey, both of these terms are the same, the variable term and the constant term on both sides. It's an infinite solution, either by working it out or stating the definition. So to practice these, and for your homework, you will have the back. And this is your homework here. And you will have to do these problems by stating them. So let's look. I'm going to show you 3 examples. I'm going to show you this one. I'm going to show you that one. And I'm going to show you this one. Okay? The first example, I look at this. I have 6p minus 4. And I have a negative 4 plus 6p. Well, my variable term is a 6p. My other term here is a 6p. My constant term is a negative 4, and my constant term is a negative 4. These are both the same. So my variable term and my constant terms are alike. So that means an infinite solution. Say you didn't recognize this and you needed to solve it. Okay, so let's solve this. I'm going to move this 6p over here. That's positive, so minus it on both sides. The 6p's go away because they go to 0, and you're left with a negative 4 is equal to a negative 4, and that is true. So that's why it's an infinite solution. Okay, you either need to work it out or state the definition. Some of these you need to work out, and then you can be able to see the definition come in. Such as this one right here. Here I can't tell if they're going to be the same, or if they're different, or what happens. I need to do some cleanups. I need to clean this guy up first. So I got 12s is equal to 4 times 3 is 12s. 4 times 9, that's a negative 9, is negative 36. Okay? So far, so good. I don't recognize it just quite yet, so I'm just going to solve it. So I'm going to move the s over here to the left-hand side. I'm going to move it over here. This is a plus, so let's just subtract. Let's see if it jumps out at us here. 12 minus 12 is 0. 12 minus 12 is 0, so I have 0 on that side is equal to a negative 36. That's false. Can't happen. So this is a no solution. And you will see here that my variable terms, 12s, are the same. but my constant terms, negative 36, and technically there's a 0 over here, are not the same. My constant term, which would be over here, I could put a 0 here if I wanted to, is not the same. So that would be a null solution. Okay? So you can state that too as well. Your variable terms are alike, but constants are not. Okay? My last one here, obviously you should know what this one should be. This is going to be a 1 solution. And I want to solve this problem. Okay? And by solving this, I'm going to get my constants over here. My solution variables over. Those go away. I'm left with 20d equals 20. Divide by 20. I'm going to get d equals 1. And that will be my answer. And I am now completed. So it's your job now to finish the rest of those for your homework. Best of luck.